This is the Statistics Chapter 6 review for the test. So on this test, there is not a whole lot of math that we're going to be doing. It's more setting up experiments and making sure that you're comfortable with the vocabulary. So first of all, you should definitely know what an observational study is. You should also know what an experiment is. And we've talked about this since the beginning of class, so you should know the difference between these two as well. So in the test, I'm going to give you a scenario, so a word problem. And what you're going to have to do is be able to tell me if it is an experiment or not based on the description of the story. In our examples, or the problems that you would have to do on the test, you have to say if it is experiment or observational. And then you would need to tell me about the explanatory variable. And remember, the explanatory variable is what we are trying to use to explain something. So if you think that watching a lot of TV would make somebody's grades go down, then the example would be the explanatory variable is that the amount of TV you watch, because we are thinking that's what's causing something else. The other thing that you would be interested in finding in the word problem is the response variable. The response variable is what you're trying to decide will happen. So in the example of the TV and the grades, then obviously the grades would be the response variable. Another way to think about it is the explanatory is the X, because there's an X in it, and response is then the Y. Make sure that you can pick out any confounding variables that might be present. So an example of a confounding variable in our last statement where I was talking about watching a lot of TV and your grades, maybe there's another confounding variable. Maybe it's not the TV that makes your grades low. Maybe your parents have to work 2 jobs and so they're never home, so they don't tell you to stop watching TV. So if your parents are never home, then they can't help you with your homework, and maybe that's why your grades are low. So a confounding variable, remember, is just another variable that might possibly be going on that is not specifically stated. Now, it is important to know confounding variables means you need to think. It is not specifically stated in the problem. You just have to read and say, well, what else could be interfering? So you actually have to think. This is not stated in the word problems. So if you notice when I told you about grades and TV time, I never said anything about parents or anything. That's just me speculating about what might possibly happen, and that's what statisticians have to do. Confounding variables are not stated. There's something you have to think about. All right, in word problems, you also need to be able to pick out the treatment. The treatment is what we are giving our patient, and it can be a combination of things. On the 6.2 homework that you guys turned in, you had to tell me all 6 treatments, and there was a high and low dose for IV treatment or pill treatment, and I can't remember what the last one was, but there were 6 possible combinations. So if I ask you what the treatments are, you have to tell me all of them, and you have to be very, very specific. Of course, you should know the placebo effect, and I think most people got this correct on the quiz. So just make sure that you know that the placebo effect, placebo is definitely a sugar pill, but if you remember, the placebo effect is reporting that you feel better, even though you had the fake treatment. So if you remember, you don't know that you've been given the fake treatment, obviously, because if you knew you had the fake treatment, you wouldn't say you're feeling better. But you've gotten this medicine and you think you're feeling better, or you report that you're having fewer headaches, or you've lost weight, or whatever the issue is that you were tested. The placebo effect means that something has changed, not that you were just given a fake treatment. And about half of you got this one incorrect on the quiz. Statistically significant. I'm going to ask about this again on the test because it's an important concept in statistics, and we're going to cover it more and more in the next chapters. This is basically saying that the results are too different to just be chance. And an example that I use with statistically significant is if I gave half of the class medicine A and I gave half of the class medicine B, and I had randomly assigned the kids. I didn't just pick like all the good kids in one and all the kids who hated math in another. What would happen is that after so many weeks of them taking this pill, I would give them a test and see who did better. And if everybody in group A made a 95 or better, and then everybody in group B just did a normal like grades, like some people got C's, some people got B's, some people got A's, you know, all that kind of stuff. If every single kid made a 95 or better on group A, I'm thinking that maybe whatever was in that medicine was really, really helping them, because it's too different from the other group who had lots of C's and B's and maybe some F's, that everybody did better. So I would say in that case that the results were statistically significant, because what I saw was too different to just say, oh, it must be chance, or oh, it must be a coincidence. It makes me think that maybe there was something to that medicine that was being given. All right, moving on. Matched pairs. Some of you left this one blank on the quiz, and then some of you put something on there that was very creative but not quite right. So we're going to be specific on what we want with matched pairs. A matched pairs is a type of pairing where the participants have similar characteristics. Okay, so what on earth does that mean, Miss Jones? I'm so glad you asked. There's two types. First of all, it is two different people. And it doesn't have to be people. So when I say people, don't take that too literally. It could be like two computers, or it could be two airplanes, or it can be two cupcakes. I really don't care. But it's two different people. It's not the same person. Or it could be more than two. So an example that I did talk about before was a shampoo example. Meaning, if I want to find the best shampoo for my hair, I could buy all kinds of brands of shampoo, and then over the next several months, just shampoo my hair with a certain type of shampoo over and over and over again, and then try the next brand, and then try the next brand. But I would never get my results fast, and I would forget how the first shampoo made my hair and all of that stuff. So what I might do is find several people who have similar hair than me, or as me. So I have very thick hair, and it's long. And so I would try to find as many participants who had long, thick hair, and I would give each of them a different brand of shampoo. And we would agree that we would all shampoo our hair every day for, 2 weeks. And then we'll come back and we'll look at our hair and see how easy is it to get a brush or a pick through. And then how shiny is it? Or do I have a lot of split ends? Or how healthy does it look? So this is a type of matched pairs where we do different things. So once again, you know, if I did 2 airplanes, I would pick 2 models of airplanes that are very similar. I wouldn't pick a really high-end one and then a really junky one. They should be the same brand and everything, and I could test the airplanes that way. That is a matched pair, and it makes sense because I matched a pair of people or computers or airplanes that look similar so that we can get results. Another option is to test on the same person. Once again, it doesn't have to be a person. It could be a computer or cupcake or whatever again. So this one might be the example of bug spray. So if I put bug spray on my right arm and I do another bug spray on my left arm, and then I go outside, I could just count how many bugs bites I get on each side, and then I've got a matched pair, but it was on myself. I didn't use 2 different people. You can probably see that there are benefits and, you know, drawbacks with both of these. But obviously, if you can test on the same person, that's going to be the best because, you know, with bugs, maybe it's a certain blood type, maybe it's what I ate that day or whatever. But if I'm testing on myself, it controls a lot of that variation. All right, next we're going on to designing experiments. So when I ask you to design an experiment, what I'm asking you to do is to actually come up with a chart or a diagram, and you're going to put all the information in there. All right, so when I design an experiment, let's just do an example. So if I said, I am baking cookies. I want to see if using margarine or butter is better. And I might test at the same time, you know, different temperatures, because maybe if I cook margarine at a very high temperature or low temperature, it's going to do better than butter at a higher or low temperature. So it's going to give me more information than just picking one certain temperature and hoping one of those fits in there. So I want to test them baked at, we'll do 300, 350, and 400, and we are looking for taste, quality, and color too, because cookies, if they're ugly and I'm trying to sell them or something, they're not going to sell. So first of all, if I asked you what were the treatments, you should notice that we have 3 temperatures and we have 2 experimental values here. So my treatments would be 300 degrees with margarine, 350 with margarine, 400 with margarine, and then I would have to test 300 with butter, 350 with butter, and 400 with butter. So you should see right away from that word problem that there are 6 treatments. Also, what I'm looking for, the response variable, is the taste, quality, and color. That's what I'm trying to see. The explanatory variables are types of butter or margarine and temperature cooked. So there can be 2 explanatory variables that we're testing. Okay, so in this thing, since I'm baking cookies, I don't start with volunteers because obviously a cookie can't volunteer. So if everything else has been held constant, the first thing I would be doing, and when you design an experiment, it has to make sense. I don't start by cooking them. I start by deciding which batch gets margarine and which gets butter. So that better come first. I should not put the temperatures first, because how do I put temperatures and then go back and decide I'm going to put butter and margarine in them? You have to do this first. I need to randomly assign which cookies get the margarine and which ones get the butter. From here, the margarine has to go at 300. at 350 and at 400. And same thing for butter. Remember, we're having to keep it constant. We have to keep as much the same as possible. When we're all finished, of course, I want to compare the different colors and tastes of cookies at the different temperatures that were made out of margarine. And then I would do the same thing for those at butter. And maybe I would take the best from each of these and then do a taste comparison and a color comparison one more time between the two of them. So this is the proper way to set up this particular design experiment. Now I want you to know that it does change based on the word problem. That is life. I'm sorry, word problems change, and so how you set up the problem would also change. Some of you prefer the table. If you prefer the table, you would have margarine, you would have butter. Pretend that says butter. Then you'd have 300, 350, and 400. And the table method, you make a table. And we know there's 6 treatments. We already talked about that. And so you would just go through and say that's treatment 1, 2, 3, 4, 5, and 6. And so both are correct ways to set them up. When I ask you to design an experiment, please do not give me a paragraph answer. I'm not going to sit and read your paragraph. I want you to follow the instructions, which are to set them up with a table. All right, from here, I then will give you a list of people. So, maybe a Bob and Joe and Bill and Sue and Pam and people like that. So I'll give you a list of them, and I will say assign them to a treatment. So what you would do is you would label all of them a number, and then on your calculator you would do rand int, or you could go to the back of the book to the number table, and you would divide them up. So let's say I was going to give somebody drug A and drug B. And maybe on my random number table, the first thing I got was 3. Well, 3, if you remember, means Bill is going to get drug A. Then the next one I got, maybe I'll add one more here. And I want to make sure it's fair, so I'm going to put 3 in drug A and 3 in drug B. So that maybe the next number I pick is 1, and so that responds to or corresponds to Bob. And then maybe my other number is 6, and that means Carol. So those 3 would be getting the drug A. Now, I don't need to do the random number table to get the rest of them. It will just be all the rest of them. So the people I didn't use, who will be in drug B, are Joe, Sue, and Pam. So that's how we do a random number table to assign people. So on the test, what it will be is I'll ask you to design an experiment, and then, that's the diagram thing, I would give you a list of names, and I would say, okay, who's getting what treatment? Now, in my cookie example, I had 6 treatments. So then that means I need to list 6 things here. So I would say butter 300, butter 350, butter 400, and then do margarine. And then I would randomly assign cookies or whatever. But, you know, in the example that you'll do on the test, it will be a drug or something like that, and you'll have actual names of patients. When you're taking the test, I want to see the numbers for sure. And I want to know where you got them from. Did you use random int or did you use a table? And then from there, I need the names too. Don't just tell me 316 and assume I know what you're talking about. Give me the actual names to get full credit. Okay. I'm going to give you some more scenarios, and in the word problems, I'm going to ask you to pick out some more information. First of all, you should be able to tell me if an experiment is single blind or double blind. Okay, so on the quiz I asked you to define it. I'm not going to ask you to define it this time. I'm going to ask you to explain it. So if I said 3 patients were randomly given drug A, B, or C, and the person administering the drug did know who was getting what kind of blind is that? It is single. If I said the patients didn't know and the person administering did not know, then we're talking about double blind. So you basically just have to categorize it based on what it is. Remember that placebo is important, because if you give somebody drug A and drug B and drug C and that's all you do, nowhere in there do we know if just giving them anything would have helped. So if you do drugs A, B, and C, you should also throw a placebo in there too. So you would actually have 4 things that you're testing. Because some people have to get a placebo unless they'll just die if they don't take the right medicine. So you want to make sure that the placebo is there to help control the placebo effect. So if we give people a bunch of placebos and all of them are saying they feel just as good as people who took drug A, then I may think it's not statistically significant because the difference between A and the placebo was not very much. All right, I'm also going to ask you the difference between a treatment variable and a block. A treatment variable is something you can change. So I can change whether you take drug A or drug B, or I can change whether you exercise or not, because maybe that's part of the experiment. Things that I cannot change are considered blocks. This could be things such as your ethnicity, having a disease or not. So if I wanted to test a drug on people who have diabetes, I'm going to block it by people maybe who have type 1 diabetes and type 2, because I cannot go in and make you get type 2 diabetes or type 1 diabetes if you don't already have it or you already have the other one. Other things such as gender, age, things like that we can't change, that is all considered a block, okay? So one of the problems on the test is I will give you a word problem and I will ask you, is what I'm describing a treatment variable or a block? And what you basically have to remember is if I can change it, it is a treatment variable. If I cannot change it, it is a block. Now, the very last part of the test is going to deal with ethics, which was our last section. So some of this, since it was not on your quiz, is going to be some memorization that you just need to do. Okay? So first of all, you need to be familiar with sham surgeries. You need to know what they are, and you need to know why they're considered unethical, or different things like that I might ask you. Okay? The next thing you need to memorize is the 3 parts of data ethics. It's just a memorization question. You don't need to do any word problems with it. First of all, if you've forgotten, a review board has to approve. You can't just give anybody medicine and put all this weird stuff in it and hope it's okay. It has to go to review board and you have to tell them what's in it and what you think might happen so they can approve whether that's ethical or not to give to humans. You have to have informed consent. You don't need to tell the patient what treatment they're getting. You're not going to be like, oh, hey, buddy, you're going to get the placebo. Go ahead and sign this. That's not informed consent. Informed consent is just saying, hey, there's the option that you may get the placebo or you may get drug A and you may get drug B. And you're going to be doing this for 2 months and you have to do this or whatever. So whatever is informed, whatever is pertinent to the case, that is going to be informed consent and they have to sign it. And then the last thing is that you have to keep the data confidential. You are not allowed to put Miss Jones on a diet pill and then post my weight to the whole world. They don't need to know. So the data keeps confidential. Apparently it's plural. Data is confidential. You need to know the difference between anonymous and confidential. Really quick, anonymous means we don't know that you are part of the survey. Confidential means I do know you're part of the survey, but I'm not going to share it with people. Okay? It's very hard to get anonymous. We talked about surveys. Some people don't put their name on it and think it's anonymous. However, there was like a QR code, or there was a barcode, or maybe just some numbers at the bottom, and that corresponded to your address. That no longer means you're anonymous, because they know who in the house did it, or that somebody in the house did that. Confidential means we know, like I said, that somebody did it or who they did it, but I just don't share the results. All right, and then just be prepared to speak about ethics in general. There's a couple other questions that I asked you about the ethics. They're not exactly memorization questions. You just need to be familiar with the content in the chapter, and you need to speak intelligently when I ask you questions about it. Okay, so if I ask you if something's ethical, don't just say yes or no. You have to give me reasons why. Okay? So that is basically a summary of what you need to know for the test. I know you guys had some trouble with setting up experiments, so we're going to do one more example, and this is actually in your book so you can follow along. So go ahead and get your books out, and we're going to turn to page 306, and we're going to work together on number 73. This should be written in your notes as well, so make sure that you are copying this down. All right, so reading 73, a drug manufacturer is studying how a new drug behaves in patients. Investigators compare two doses, 5 milligrams and 10 milligrams. The drug can be administered by injection, by a skin patch, or an intravenous drip. Concentration in the blood after 30 minutes, which is the response variable, may depend both on the dose and the method of administration. Make a sketch that describes the treatments formed by combining doses and method, and then use a diagram to outline a completely randomized design for this experiment. Now, because it is a new drug on patients, we actually will have volunteers last time. Remember with the cookie one, we did not have volunteers because cookies are not going to volunteer, but people will. So we're going to start with volunteers. Okay? Now, we have to decide which would come first. Would it make more sense to talk about their dosage amount or how they would get the dosage first? Well, hopefully you would say how they get the dosage should come before how much is going to be in that dose. So if you remember, there were 3 ways they could get that dose. So we're going to start off with 3 branches. So you could get it injected. You could get it with a patch, or you could get the IV drip. These are not blocks, so it is something I can control. So when I have my patients, I don't just put like the first 5 in inject and then go with patch and then go with IV. There might be some underlying issues, so we have to put the word random there because I need to randomly select who gets the IV, who gets the patch, and who gets the injections. So I put random on all 3. Okay? Now, we're going to actually have to do random again because now I have to decide if the injection patient gets 5 doses, or the 5 grams, or if that patient gets 10. I'm going to just put R's because you can understand writing on this little whiteboard is not easy. So they all get randoms. Please don't put the word random if it doesn't make sense or if it's blocked. If I say type A and type B or type 1 and type 2 diabetes, you better not put random here because you don't randomly give somebody diabetes. Random goes when we need to control some things that are going on. Okay? So now I've got injection with 5, injection with 10, patch with 5, patch with 10, and IV drip with 5 and IV drip with 10. After we're done with that, after time, we're going to take all of this and compare. Why didn't I draw little lines here to say compare? Well, you could. There's nothing magical about how we compare, but eventually we do want to compare all of them. So when I draw the bar like this, what I'm basically saying is I'm going to look at all 6 treatments at the same time. If I divide them up like this first, that means I would look at these 2, and these 2, and then pick the best of each and then compare it one more time. So that's why sometimes you'll see me do one big branch and sometimes you'll see the little ones and then one more. So hopefully that helps you. All right, so here, if I asked you, what are the treatments? Well, if you set up your diagram correctly, it's actually beautiful because you just follow the bars. Okay, so we have inject 5, inject 10, patch 5, patch 10, ooh, can't spell, and then IV 5, and IV 10. You can see there are 6 treatments here, and here we have 6 lines that are going to different treatments. Part B says, how many subjects is a tough issue? What is the advantage of using a larger group of people? So that was A. Why on earth would we want more people? It's more people who could possibly drop out or be a non-adherer or, you know, just mess it up in some way. So why would I want more people? Well, the short answer is that you just get more data. And the more data we have, the more reliable our results are. Also, another important thing is that if some drop out, we still have plenty of people to test. I'm going to use the example of the dance team for Barbados. If I had a large group and some people dropped out, it wouldn't be such a big deal. But if I have a small group and half of them drop out, then it changes what the dance looks like. I'm not hating on you, just saying. And then C, the drug may have different or behave differently on men and women. So how would you modify your experimental design to take this into account? Well, first of all, I would say after volunteers, let's look at our diagram again. Where would I change women and men? Well, it obviously would come between deciding what dose you get, and it probably would even come before which type of treatment you're going to get. So right after volunteers, you would draw 2 lines, and one would be men and one would be women, and from the men, they would get inject, patch, IV, and you would continue. And from women, we'd basically repeat this whole diagram again. So this diagram would show up twice. We'd have it down here and up here, one for men and one for men. Women and men. Okay. So after volunteers, we would insert men and women. Is this a treatment variable or a block? Hopefully you said block. Okay. We don't want to force people to have a gender changing surgery so that they can be randomly assigned as a man or woman. That's not cool. So we're going to treat it as a block. You're either a man, you're a woman, then we're going to treat you differently. And we would block men and women to make sure that equal numbers of each were given different treatments so that we could compare if the drug works differently in men and women. Okay? Make sure that if you do a block on a diagram, so if I started with volunteers and we started with men and women, I would not put the word random here because once again it's a block. I don't randomly decide if you're a man or a woman. And then from here we would have our 3. Random would go on these branches. And then of course from there you have the 2 more branches and these still stay random. So the only thing that changed in our experiment is we basically doubled the whole thing because we had to split at the very beginning between men and women as a block. Okay, so So what you're going to do for the rest of the class is you're going to work on some practice problems and making sure that you ask me questions, if you have any, before the test. So after you reviewed this video, remember you can go back and play it at any time. Make sure you've gotten down all the things that you need to do. If you need to replay some of the examples, or even better yet, you know, maybe in a day or two, go back to number 73 and try to set it up all by yourself, and then go back to the video and see if you did it correctly. So there's some good ways to practice. Really with the this test, because some of it is just memorization, some of it's setting up experiments, but a lot of it is reading and applying what you know. So you can know what the definition of double blind is all day long, but unless you can read a story problem and say, oh yeah, that's definitely double blind, it's not going to help you much in real life. So as you're doing these problems that I'm about to assign, make sure that you feel comfortable setting them up, and that you're comfortable finding things like treatments, experimental values, explanatory variables, response variables, different things like that. And obviously that we know the difference between a treatment and a block. All right, so I hope you have a wonderful day.